Alright guys, we're going to do lesson 9-1 today, which is properties of exponents. And today we're going to be learning about two important laws of powers. Okay, the first one is going to be multiplying powers. The second one we will talk about is dividing powers. And these are only true when we have this same base. Okay, so you can only use these powers, or these laws for multiplying powers or dividing powers when we have the same base. So let's take a look at number one. We're going to multiply 3 to the third power times 3 to the fourth power. Now before we multiply this out, let's go ahead and expand this. What I mean by that, we're going to show this as repeated addition. So for 3 to the third power, that's really saying 3 times 3 times 3. And 3 to the fourth power, so we're going to multiply this times 3 to the fourth power, which is 3 times 3 times 3 times 3. Okay, so when we expand that out, really, we have 1, 2, 3, 4, 5, 6, 7 3's. So we're multiplying 3 times itself 7 times. Well, isn't that what 3 plus 4 is equal to? All we had to do for this problem is write down the common base, which was 3, and add the exponents, which was 3 plus 4, and we would get 3 to the 7th power. Okay, so let's take a look at number 2. Let's see if we can do the same thing with number 2. Well, we have the same base for number 2. We have an A and an A, so I'm going to go ahead and expand these out. A squared is really A times A. I have 2 A's. And then we're multiplying that by A to the third, which is A times A times A. Okay, and what we want to do now is count up all the A's that we have, which really, we have A to the 5th power. And again, we would add that 2 plus 3 to get A to the 5th. So let's try one more down here. These are getting a little more complicated. This time we have a couple of different bases. So what we want to do is group together the common bases and use that same law that we were just using by adding the exponents. So let's take a look at number 5. See, I have 2 coefficients out in front, 4 and 3. Okay, what we're going to do with those is just multiply them like we normally would. So 4 times 3 would give me 12. And then I want to take a look at my y's. I have a y to the 2nd power and a y to the 3rd power. Now, instead of expanding all of this out, we're going to use that law of exponents we just talked about. And I'm going to take the exponents 2 and 3, and I'm going to add them together. So 2 plus 3 is 5. So my answer would be 12y to the 5th. Okay, so we just multiplied the coefficients in front. We wrote the common base y and added the exponents. Okay, let's take a look at number 6. Number 6, I have 2 different bases. I have an A and an A. Let's see, A to the 3rd and A squared. I'm going to write down that common base, and I'm going to add the exponents. So 3 plus 2 will give me 5. I just added the 3 and the 2. And then the second base we have is a B. We have B squared and B to the 4th. So again, I'm going to write down that base, and I'm going to add the exponents. 2 plus 4 gives me 6. So when I multiply these together, my answer is going to be A to the 5th, B to the 6th. So let's see if you can do a couple examples. I want you to write down in your notes number 1 here, and I want you to do x to the 4th times x to the 5th. See if you can multiply those together and find your answer for x to the 4th times x to the 5th. Alright, so we would want to write down the common base, which is x, and then we'd add the exponents. 4 plus 5 would give me x to the 9th. So x to the 9th would be my final answer for number 1. Why don't we try doing one more? this time, we're going to do m to the third n squared times m to the fifth n to the fourth. Okay, so why don't you press pause a minute and see if you can multiply this out and come up with your final answer. Okay, so we have two different bases here. I've got some m's. I have m to the third and n to the fifth. So if I write down that base, I'll add its exponents, 3 plus 5, and get 8. We also have n squared and n to the fourth, so I write down my n and add the exponents. 2 plus 4 is 6. So my final answer would be m to the 8th, n to the 6th. All right, let's talk about dividing powers now. Okay, when we divide powers with the same base, it's similar to multiplying, except that this time we're going to subtract the exponents. Okay? So again, this only works when you have the same base. You have to have the same base. If we look at number 1, if we were to expand this out, we would have a fraction that looks like this. 4 times 4 times 4 on top. That's representing 4 to the third power. And on the bottom, we would have 4 squared, or 4 times 4. Now we've learned that anytime you have a number divided by itself, it's equal to 1. So that means that these two 4's would cancel out, and this pair of 4's would cancel out. That'd just be like saying 1 times 4. So my final answer would just be 4, or we could say 4 to the first power. Now if you were to look at this problem without expanding it out, we could have, using this new law that we're learning, written down the common base and subtracted the exponents. So we would do 3 minus 2 and get 4 to the first power. Okay? So that's our law for dividing powers with the same base. We're writing the common base and then subtracting the exponents. So let's try number 2. If we take a look at number 2, my common base is a. So I'm going to write that down. And then I'm going to subtract the exponents. 5 minus 2 is 3. A to the third would be my final answer. And lastly, number 3 over here, x is my common base. I would do 6 minus 4 and get x to the second power. And that would be my final answer. Again, this is only with exponents that have the same base. All right, let's take a look at dividing powers with different bases. We're going to split these apart into common bases just like we did with the multiplying. So if we take a look at number 4, we see that we have a coefficient in front. We have an 8 and a 2. We'll divide those like we normally would. 8 divided by 2 is 4. Then we see that we have some m's. So I'm going to write down that common base and subtract the exponents. 4 minus 3 is 1. So I can put a 1 there. And then lastly, we have n, so I'm going to write down n for my common base and subtract 5 minus 2 to get 3. So my answer is going to be 4 m to the first power, n to the third, or if we want to make it more simplified, we could write 4m n to the third. Okay, we don't have to put the 1 there. We can write it in our simplest form right here. Okay, let's do one more. Let's take a look at number 5. We're going to write the common base. I have an a, and I'm going to subtract the exponent. I have a 4 minus, because we don't have a number here for a, we're going to say a to the first power. So I'm going to subtract 4 minus 1 and get 3. And then we'll write our common base b and subtract 3 minus 2 and get 1. And again, if we want to write this more simplified, we would say a to the third b. And that would be our final answer. So lastly, we're going to do 2 more example problems. Let's make this number 3 and number 4. For number 3, go ahead and divide x to the 10 divided by x to the 6th. And for number 4, we'll say m to the 4th and the 7 over
m to the third, n to the fifth.
Okay, let's take a look at number 3. Go ahead and press pause now, see if you can do these two problems on your own. Okay, for number 3, we see that we have the same base here. We have some x's, so I'm going to write my common base down, and then I'm going to subtract the exponents. 10 minus 6 is 4. So our final answer is x to the 4th. And for number 4, I would write down my common base, which is m, and I'll subtract the exponents. 4 minus 3 is 1. And I'll also write down my n and subtract the exponents. 7 minus 5 is 2. And if we want to make that a little more simplified, we would say m n squared. And that would be our final answer.